Hi friends, today's topic of discussion is a problem from the chapter Design of Power Screws. Here, the bearing or the collar friction is neglected. The problem given is a double start square threaded power screw of nominal diameter 100 mm and pitch 12 mm is to be used to raise the load of 300 kN. The coefficient of friction at screw thread is 0.15. Neglect collar friction. Calculate torque required to raise the load and efficiency of the screw. Here I have tried to explain the double start or two start square thread where lead is equal to 2 pitch. So here this I have explained with the help of the diagram. This is the pitch and this is the lead, as it is double start or two start square thread. So in this problem it is asked to find the torque which is required to raise the load and its efficiency. So this is the information which has been provided, that is the nominal diameter DO, that is 100 mm, pitch, that is 12 mm, W, that is the load, is equal to 300 kilonewton, which I have converted into 300 into 10 raised to 3 Newton, and mu, that is coefficient of friction, as 0.15. So basically we need to calculate torque which is required to raise the load. Here mainly it has to overcome the friction between screw and nut. So T1 is equal to W, that is the load, into tan alpha, and here alpha is the helix angle in degrees and this is phi, which is the angle of friction in degrees, into D by 2, where D is the mean diameter. So load is already given, alpha we need to calculate and phi we need to calculate, and D, that is the mean diameter, we need to calculate. Let's see how we will calculate it. So first, since it is a double start square thread, we will find the lead. Lead is equal to 2 into pitch, so we got 24 lead, and the core diameter is equal to nominal diameter minus pitch, so we have 100 minus 12, because nominal diameter is given as 100 and pitch is given as 12, so we got 88 mm. So mean diameter will be nominal diameter plus the core diameter divided by 2, so we got here 94 mm. So to find alpha, we will use the formula tan alpha is equal to lead upon pi d. So with this, since we know the lead which we have calculated here and we now have the mean diameter, we can get alpha. So here we got alpha as 4.6463 degrees. And now to find phi, we know that mu, that is the coefficient of friction, is equal to tan phi. So from this we can find phi. So phi is equal to tan inverse 0.15, that is given coefficient of friction in the problem. So we got phi is equal to 8.5307 degrees. So now we got all the required information. W is already given, which we converted into Newton. We now have alpha, we now have phi, and we have the mean diameter. When we put the values, we got T1. So T1 is equal to 3301.15 into 10 raised to 3 Newton mm. So now we need to find the total torque. So T is equal to T1 plus T2, but it is already given that collar friction has to be neglected, therefore T2 will be 0. So therefore T will be equal to 3301.15 into 10 raised to 3 Newton mm, because T2 is equal to 0. And now it has been given to find the efficiency of the screw, and efficiency formula when the collar friction is neglected is tan alpha upon tan alpha plus phi. As we have already calculated alpha and we have calculated phi, so we can put the values and we can get the efficiency of the screw when the collar friction is neglected. Here we got as 0.3471, which can be written as 34.71%. So this was the problem from the chapter Design of Power Screw, where bearing or the collar friction is neglected. Please like, comment, share and subscribe. Thanks for watching.